So let's look at some arithmetic we can do with inverses. So if we've got two invertible matrices, we'll call them A and B, and we've got some non-zero scalar, then let's see what we can say about the inverses of, say, A inverse, a scalar multiple of A product, and a transpose. Well, the first one, the inverse of A, that's A. Okay, so that might sound plausible, but what if I were to ask you to prove it? How can you tell that this is definitely the case? Well, let's see. What does it mean to be the inverse? Well, to say that A is the inverse of A inverse, that means that A is the thing that if I put it next to the guy in the green box here, I get the identity. So let's write the guy in the green box and say, okay, so is it true that if I take this character and multiply it, that I get the identity? And you say, well, yes, that's exactly the definition of A inverse. So, yes, that one's totally fine. Okay. Now, with that line of reasoning, maybe we can figure out what the inverses of these other matrices are. So let's see. CA inverse is what now? Well, whatever it is, it should be the thing that you put next to CA so that when you multiply them together, you get the identity. Okay. And what about the product? Well, the inverse of AB should be the thing that you put next to AB. So the inverse of AB is going to be the thing that goes in the blue blank right here, so that when you multiply these out, you get the identity. And of course, you have to do the multiplication on both sides, but just to keep it simple for now, I'm only writing it with putting the inverse on the left side, or on the right side of the thing that we're interested in. And then lastly, the inverse of A transpose is going to be the thing that you put right here next to A transpose, so that when you multiply, you get the identity. Okay, so I want you to pause the video now and figure out what each of these blue blanks should be for parts parts 2, 3, and 4 of the theorem. Fill in those blanks on your scratch paper or whatever, and then restart the video and we'll go and check your answers. Okay, so for the first one, the answer is 1 over C times A inverse. And so you can see now that if I multiply these two things together, I can pull the constants out to the front. Constants are slippery. You can put them wherever you want. And then we have this. And we know that C times C inverse is going to give you 1. And A times A inverse is going to give you the identity. And the identity times 1 is equal to the identity. And a quick mental check will show you that if you put 1 over C A inverse on the other side, then it also works. And you know we're allowed to talk about A inverse because back here in the very beginning, we said we're assuming that A and B are invertible, so we know it exists. Okay, so the inverse of CA is 1 over C A inverse. Okay, if you haven't already done your guesses for part 3 and 4, go ahead and do that now and pause the video. Okay, so for this one, the answer is B inverse A inverse. So just like with the transpose, when you apply it to a product, it actually reverses the order. So let's see why this works. Well, now when we do the arithmetic, we can rearrange the parentheses however we like. And I'm going to put them here. And then that's going to cancel off and give the identity matrix. And so this will reduce to A inverse. And then those guys are going to cancel to the identity matrix. And I'm going to just be left with the identity matrix. So since I got to the identity, then I know that that thing that I put in the blue underline back here in the beginning really was the inverse. So the answer is B inverse, A inverse. And if you do it on the other side, you'll see the similar thing happens, but the A's cancel first. And then for the last one, the answer is A inverse transpose. So we're given that the inverse of A exists, and you can always transpose a matrix. So we'll take that. So let's see. So we've got A transpose, A inverse transpose. Now the way that transpose works, so I haven't done anything yet here. I just took the parentheses off the first guy. The way the transpose works, we can pull the transpose out, and we know that when we do this, the order of these things switch places. So we have A inverse A. That's by our rule for transposes of products. So maybe I'll just write that in miniature here. And now we can combine these inverse guys to get the identity. And we're looking at the identity transpose, but the transpose of the identity is just the identity because it's a diagonal matrix. Okay, so that gives us our fourth formula, which is A inverse transpose. All right, so now you know the formulas for the inverses of A inverse, a scalar multiple of A product, AB, and A transpose. And you also know how to figure out where they come from. The end.